So thanks a lot for the invitation, Christian. And we move to 147.Green, a Danish pyrolysis equipment producer. I'm heading marketing and business development at 147.Green, and happy to present to you here today. You can actually see a photo behind me of the industrial installation or commercial installation we have in 2 sites in Denmark at the moment. And the topic I'll talk about is removal of organic pollutants in biocides, but also I'll touch a little bit as a surprise and add on. I'll talk a little bit about removing organic pollutants in wastewater as well via the integrated drying and pyrolysis that 147.Green has. Just to put it into context very briefly, there is today a growing need for sludge pyrolysis to remove micropollutants. We have new requirements in the Urban Wastewater Treatment Directive for removing pharmaceuticals and microplastics. And there's also a recent demand on monitoring PFAS, and if you have PFAS, to do something about it. Also, the EU Commission has decided that there will be PFAS limit values for sludge in the next update of the Sewage Sludge Directive. And in Denmark, where I come from, we happen to be the first country in the world with PFAS limit values for sludge, meaning that, or as a consequence, 20% of the Danish sludge is contaminated, and the disposal costs in Denmark have gone from 50 to 500 euro per ton for the PFAS contaminated sludge. So that's a huge headache, and contaminated sludge is piling up in Denmark as we speak. Also in Europe as such, there's a lot of climate targets both at country and municipal levels. And here it's often overlooked that sludge, when it's stored for 6 months and then put on farmland, it's actually emitting at least 1.5 tons of CO2 equivalent per ton of dry matter. So it is a huge hidden emitter of greenhouse gases. And lastly, also from a financial point of view, there's limitations on land use, and the costs are increasing in most countries all over Europe and globally as well. Briefly about why do we call our technology a future-proof sludge management. It is, you would say, a technology that we have developed, which is integrating steam drying and pyrolysis of sludge in one continuous, fully automated system. So it can be operated by any unskilled worker, and you would say actually overlooked by any unskilled workers because it's operating on its own. Today we have 2 commercial plants in Denmark and 3 more projects on the way. We will be commissioning more plants end of this year, and another one in Sweden in the coming year. In order to deliver, we are still an SME. We have about 35 people doing the design and the procurement, commissioning and sales. But we have also the pleasure of now working together with Alfa Laval for delivering projects in target countries around the world. So this is a new event since the last month and so. I will not go into deep details about our technology, but it's important to understand, you would say, that the process that we have, we dry at 120 degrees C for 2 hours. And then this is followed by pyrolysis at 650 degrees C for 10 minutes. And finalized with burning of the syngas at 900 degrees C. And through this process, we see from our measurements, as well as from academic literature of similar systems, we see a complete or nearly complete removal of organic micropollutants. So this is, of course, very important in the context today where we see that there's more and more concern about unknown organic micropollutants in sludge as such, and also in applying sludge on farmland. The process, as I mentioned, is fully automated, and that, of course, also guarantees a reproducible process based on more than 100 sensors for the automation. So also, we do not see day to day or hour to hour or variations as such, because the system is running according to preset set points in terms of temperature and residence times. And as such, we can also guarantee that the results will be the same from day to day and from sludge to sludge as well. When we look at emissions from the system, we meet the European emission limit levels, and you could say the flue gas passes and the flue gas characteristics are excellent. And actually, when you stand next to our plant that is treating sludge from 40,000 people, the emissions is looking like what you see from a truck. And at the same time, we're taking 9 out of 10 trucks off the road because we reduce the biosolids quantity with a factor 10. Then moving to the data we have on organic pollutant elimination, we see that both PFAS, microplastics, pharmaceuticals, and the dioxins and PCB, PCDD, and surfactants, LAS, DHP, they are all removed. We also see that we have very low levels of PAH in the system. If either they are non-detectable or they are between 10 and 30 times below the lowest limit values we have. And this is due to the design of our system. While we eliminate all other organic pollutants, PAH is actually formed in the pyrolysis process. This is polycyclic aromatic hydrocarbons. They're formed in the syngas, and then it's a matter of having a good design where you make sure that the syngas is not condensing on the biochar when you extract the biochar from the system. And this we have also accomplished in a very good way. Most of the heavy metals will stay in the biochar, but the good news is that they are heavily immobilized. And when we look at leaching data, even in academic literature, I'll come back to that, we see that the heavy metals are much less available in biochar compared to the biosolids that is spread on farmland today. Also in the system, you could say we eliminate any malodor. The biochar is odorless, but also in our case, we have a completely closed biosolids drying and pyrolysis system with a slight negative pressure. So the only emissions you have is from the chimney, where you have mainly CO2 and looking at the data, the microplastics are reported in a number of publications to be eliminated when you pyrolyze above 550 degrees C. The methods for measuring microplastics are not that easy, so we rely on academic literature here to convince ourselves and others that there will not be any microplastics left in the biochar. They will all evaporate within seconds at 500 degrees C or 550 degrees C and go into the syngas, which is subsequently burned. When we look at PFAS, initially a couple of years ago, there was a lot of surprise that pyrolysis can do the job at much lower temperature than incineration. We have analyzed PFAS elimination in 7 different cases. In one of the cases that I'm showing here, from the most contaminated sludge we know in Denmark, with around 57 microgram per kilogram dry matter of PFAS. And the biochar resulting from this had no detectable PFAS. We have seen in 2 out of 7 instances small amounts of PFAS residing in the biochar. So you would say on average, we eliminate 99% of the PFAS that is measured when we look at the biochar coming out. The hypothesis here is that PFAS is eliminated or by another pathway than what you see when you incinerate. So during the pyrolysis, you have about 20% hydrogen present in the syngas, in the pyrolysis gas. And this huge excess of hydrogen is enabling an exchange of fluor and hydrogen on the backbone of the carbon. So we basically, the hypothesis is that hydrogen is released, fluor is released as inorganic fluor, and the hydrogen goes into the PFAS backbone and creates a normal hydrocarbon. Here you can see data in the top on PFAS levels in sludge. And in the second line, you can see the PFAS-4 levels in the biochar, and also PFAS-22. We can see the levels measured here. And in the biochar, we can see also that 5 out of 7 times the PFAS levels are below the limit of detection. What happens then with the flue gas has been a question asked many times. And here we have also had measurements done by the Eurofins with accredited measurements. And here they extend the package of PFAS compounds that they are measuring, also including potentially partially hydrogenated degradation products. And you would say the measurement package involves also short chain PFAS. So if the PFAS we see in the biochar, typically PFOS and PFOA that have 8 carbon atoms in the chain, if they were to degrade, they would pop up as also C4 or C6 carbon chains, and we do not detect any of those either. So both before and after our scrubber, we cannot detect any PFAS in the flue gas. And this is also now corroborated by a number of academic studies, listing a list here of different studies where we see similar results that when you measure the flue gas after combusting the syngas, there's a widely seen elimination of PFAS in the systems like ours. Also, same kind of elimination ranges are reported above 95%, typically when you pyrolyze at 500 degrees C, and typically around more than 97 to 98% when you pyrolyze at 650 degrees C that we do. When we look at the other micropollutants that we are measuring according to Danish and European legislation, we also see that the LAS, DHP2 surfactants and chlorinated compounds like PCB, PCDD, and PCDF, they are non-detectable in the biochar. We see the same with the pesticides. Here we typically see 5 to 10 different pesticides in the biosolids. And we also see with the pharmaceuticals that more than 99% of these are eliminated. Eurofins has a package of 157 pharmaceuticals that they analyze. And we typically see between 25 and 40 of those in the biosolids that we have been analyzing. And when it comes to analyzing the biochar, we either don't see any, or sometimes we see between 1 and 4 traces of 1 to 4 pharmaceuticals present in the biochar. So overall, we also from a toxicity point of view, more than 99% are eliminated. And then as mentioned, our system mechanical design is ensuring that we have low PAH levels. In our case, PAH 9 is measured, and here we see levels below 0.4 milligram per kilogram dry matter, and typically either non-detectable or below 0.2, I would say. When we look at immobilization of heavy metals, there's a very interesting Australian study on biosolids biochar from 2 different wastewater treatment plants. And here they have accelerated the release of heavy metals by oxidizing both the biosolids and the biochar with hydrogen peroxide. And you can see that once you pyrolyze at 600 degrees C or higher temperature, the curve is absolutely at the bottom at 0 or very, very close to 0, which is signifying that there's no leaching of the heavy metals from the biochar. The data on the leaching from biosolids once they oxidize are the numbers up here, and basically the leaching from aged biosolids or oxidized biosolids, the heavy metal leaching is increasing dramatically. If you look at copper, for example, it's increasing from 6 to 140, or for zinc, it's increasing from 142, etc. So even though the concentration of heavy metals is doubling, the bioavailability of the heavy metals is drastically reduced in the biosolids. In the biochar. I think I have a few minutes more just to also talk about why can the biochar be good for removing micropollutants in wastewater. There's a lot of focus on this now after a presentation given by a Norwegian research group in Sweden in June 23, where they basically reported that biosolid biochar is surprisingly good to eliminate PFAS from or soft PFAS from wastewater. And here shows that it can be up to 100,000 times better than wood-based biochar, simply due to that the pore size in biosolids biochar is 20 to 40 times bigger than what you get in wood-based biochar. This is specifically good for sorbing PFAS compounds. There's still a lot of research ongoing, and we will be participating in that and following that. It seems that pyrolysis at 700 degrees C has a very important impact on the pore size. So we will also be looking at our system. Should we go from 650 to 700 degrees C or 750 degrees C? If we want to tailor biochar for removing micropollutants within the wastewater treatment plant itself. So you can imagine a circular system where you produce your own biochar, you use it in your wastewater treatment plant to polish the wastewater, and then you directly capture the used biochar together with the sludge that is produced and take it back into your drying and pyrolysis plant for creating new virgin biochar without the. So this is a very interesting aspect, and we believe that will also at least double the value of the biochar compared to the value it can have in other applications. We have just now completed a research project with Aarhus University and 3 Danish utilities, where sludge-derived biochar, in this case here, it is data under the letter E, which is the orange line here, and the conclusion from the data from the research work, where you would say filtration of pharmaceuticals, more than 50 compounds have been tested. The conclusion is both wood-based biochar and sludge-derived biochar is performing very well, capturing most of the components that have been tested. In some cases, the activated carbon is better, so we are not saying that you can substitute all activated carbon, but you can probably go in and substitute maybe a third of your activated carbon, or maybe even half, with biochar from biosolids in a system where you want to polish and take out pharmaceuticals from your wastewater. So this will be very interesting to test in the future as well. Just the last slide on you could say practicalities in terms of applying this technology. We look at roughly 1 year from design to commissioning, so roughly a couple of months for designing, about 6 months for manufacturing a plant, and 4 months for installation and commissioning. And then depending on your mentality, you can either run the authority approvals in parallel, or you can do them sequentially. And then, of course, if you want to wait for the authority approvals, that would go in on top in a project timeline. But we are, as I mentioned, we have projects now in Denmark and Sweden, and we have a lot of interest in many countries in Europe. And we are also lately looking towards both US and Australia as we speak. So exciting time for sludge pyrolysis, and I think it's a future-proof technology that is meeting the needs and the macro trends that we see in the segment here for wastewater treatment. Thanks a lot for your attention, and I look forward to listening to and answering all the questions you may have.
Thank you very much, Christian. Nice to see that you did a lot of research on contamination.
Yes.
My first quick question: are you now allowed in Denmark to use biosolid char on agricultural fields?
Yes, and the good news is that it's expanding. You would say country by country. So now it's also possible in Sweden, Finland, Estonia, and Czech Republic. And the latest news I got, which I haven't verified, is that it's also allowed in UK. So it's maybe you know that. There was a customer or potential customer telling me that biosolids biochar is actually regulated as biosolids in the UK, so it can be applied on farmland if it meets the same limit values as the biosolids itself.
Yeah, I think the UK is a bit tricky with regulation because no one really know what's regulated.
Okay.
And apparently the environmental agency as well. So they're a bit
okay.
Yeah, confused too.
There was an optimist in from UK that I spoke to a week ago.
So you got a couple of questions in the chat. So I think we have to make a short answers because otherwise we cannot even go halfway through. So Jacek was asking, what are the allowable levels in PFAS species in the EU in wastewater? Are these country-specific regulations?
So in the EU there are no limit values yet. There's a new wording in the new urban wastewater treatment directive that you have to measure it, and it's up to each country to be responsible for that their wastewater is not harmful. So now it's up to each nation to decide what levels are harmful and not harmful, but there is an obligation to start monitoring PFAS in wastewater in all EU countries, and that kicks in a couple of years. There is a grace period until this takes effect, a couple of years.
Okay. So Sven was asking, is some portion of the heavy metals escaping into the exhaust gas flow? And do you have a filter for these?
Yes, we have a scrubber. So we will see mercury is evaporating and small, but the amounts are so small that we can hardly measure them. You can see that our limit values in the emissions also have measure heavy metals, and we are way below the limit values for heavy metals in our emissions. But we do see most of the heavy emissions will will be filtered or caught in the scrubber, in a wet scrubber.
Sorry, I have to jump through these questions. There are too many. Marshall was asking, what's the throughput of your system? I think you mentioned 5,700 tons of biosolids.
So we have two models, one treating 3,500 tons of biosolids and another one treating the 50% more, so around 5,300 tons of biosolids annually.
And a follow-up question on that, can this be integrated into an already set up wastewater plant?
Yes, it is just set up in the end after your dewatering.
And do you have a maximum level for moisture content that goes into your system?
So any typical dewatering will work. I mean, we want it to be at 18+% dry solids. So yeah.
Okay, so still free flowing, but not just water.
The sludge should not be free flowing. There should not be water separating from it. It should be, I think they call it pallet. Yes. So you should be able to shovel it. If you put it on the table, it should not.
Yeah, should not flow away.
It should not flow away.
Okay. Then another question from Marshall: what is the use of the biochar in your case? Soil applications or?
Yeah, there's an interest in using it in urban landscaping.
Okay.
So it's for tree planting in cities or forestry as well. And there's also an interest for using it in agriculture, but I think we haven't found the final use of that. And then there's an interest in using it in more industrial applications, as well as using it as a filtration medium.
And I guess the main goal is there to get a higher value product for the filtration applications, or?
So for the filtration application, the thought is to use it within the wastewater treatment plant itself.
Okay.
So you can save on your
Okay.
Yeah.
Leon was asking, which new markets are you targeting for your sludge pyrolysis expansion?
So we're not ruling out any markets if we have interesting clients. We are today having projects in our near markets, but we are also in a dialogue with a lot of clients in Europe, UK, and Italy, standing out in Europe. Then we have.
Sorry, your audio is breaking up a bit.
So UK and Italy are important markets in Europe right now, and also Australia and US will become very important markets.
Yeah, I think the UK is still a good market, even though the regulation is really weird, because there are so many issues with sludge. So a good growth market. And what are the sales projections of your company? Do you doubling in 2 years or any?
Yeah, we will double for sure, I think. So we are currently, you could say, in the range of selling 3 to 5 plants in a year. And I think with the demand we have in 2 years' time, we will definitely be delivering more projects. So together with Val as a partner, we also plan to move, you could say, to copy the production that we have in Denmark now, potentially also in other regions, to take the blueprint to other regions and be able to deliver there. And our delivery capability will be more than doubled together with Alfa Laval for sure.
Okay. Chris was asking, you mentioned the system is fully automatic. How does the selection and feed system fit into this scenario?
So if I understand right, I mean, we can run on any municipal sewage sludge. If it's digested or non-digested, the system is adapting to that. So, and if we don't have sufficient, you would say often the system is autothermal, so we get the drying for free. But in the cases where there's not enough energy in the sludge, then the system is adding energy by itself. So you could say in that sense, it is it can run on any kind of sludge.
And have you tried on manure? So
No, well, we have, yes, and it can run on manure, but we are the configuration of the dryer is for non-fibrous material. So if we start working on manure, we would have to do some modifications and have some have a cyclone, for example, in our steam dryer to catch fibrous material.
Okay.
So for that reason, we are looking at you say focusing on municipal solutions.
And then the question that I guess you always get in this kind of presentations: what's the cost of your minimum setup?
So the small unit has a cost in the range of 3 million euro plus. You could say the cost of a building is roughly 40% on top. So the range is 4 million euros.
And that's including the dryer.
That's for the dryer and the pyrolysis. It's one solution.
Okay.
Yeah, we're not selling them separately.
And a last question, more general. I think many of us have seen the Danish government announcement about biochar carbon removal credits. Have you heard anything about, or are you already planning to apply somewhere, or do you have any news on that?
That's mainly for the agricultural segment.
Okay.
So at the moment we will be looking into it, but we would say the program here is for reducing.
Okay.